Obrigado a Juan Escobar, que está trazendo também um tópico sobre escada. Obrigado mais uma vez por estar com a gente e é com você, Juan.
Thank you, Rafael, for the invitation to this Cybersecurity Summit. I'm glad to be here. So also, hello to everyone. I hope that you and your families are well. My name is Juan Escobar, and I work as a senior cybersecurity consultant at DreamLab Technologies, and in Chile at the moment. Chile is a land of excellent wine, and also we have so many earthquakes. About DreamLab, DreamLab is a pioneer switch company and source of constant innovation in the cybersecurity landscape, with 20 years of experience in almost all sectors of the industry, and with a presence in various regions of the world. So this talk is based on our experience in the field of security audits, incident response, as well as the research of new vulnerabilities and how they are applied to the ICS KillChain. So as a small introduction, what are industrial control systems? ICS are devices that generally operate in critical infrastructures. These are not well known since they operate in a different environment compared with companies that have common information technologies. Also, many incidents involving ICS device and the OT environment have had very important geopolitical connotation, which has changed the world related to the vulnerabilities existing in them, which has led governments to take measures to classify them as a critical element of the nation. So, as many of you probably know, today we are in what is called Industry 4.0, which is characterized by broad interconnectivity, data collection, analysis, and communication, which results in the optimization of the flow and quality of processes. Although the benefits of many of these convergence between the IT and the OT worlds increases the attack surface and as well as the number of new controls to implement. Based on this premise is that in the 19th, Theodore J. Williams, along with members of the Purdue University Consortium, developed the Purdue Enterprise Reference Architecture as a model for enterprise architectures, where the Purdue model defines the different levels of critical infrastructure that are used in production lines and the way to secure them. But as we know, it is very difficult to implement, maintain, and monitor all cybersecurity systems. We must remember that not all companies are the same. Therefore, the security mechanism and architecture are different, but at the base, the activities to be carried out by an attacker will almost always be the same. And that is why Michael J. Asante and Robert M. Lee adapted the KillChain model created by Lockheed Martin to the ICS world to understand, visualize, and organize the steps required for an adversary to reach their goal. So the ICS KillChain consists in two phases: cyber intrusion, preparation, and execution. And we can call this phase as IT, and ICS attack development and execution. And this can call this OT. So let's see what these steps are. For stage one, the first one is recognizance. Recognizance is an activity to obtain information about something through observation and or other detection methods. This activity is divided into two: passive and active reconnaissance, where the passive is in charge of searching for the information available in public source, and the active interacts directly with the target for the collection of information. Okay, so let's continue. First, let's define our target and the attacker. In this case, the target is a nuclear power plant called Macros, and the attackers will be a group called APT666. If we search for this nuclear plant in Google, we have a result. And if we open this result, we will see that this plant is located in Switzerland and also have other energy generation projects. Continuing with the passive reconnaissance, we can also do search in Shodan and SumI, where probably there is not much information, which always should be the case. Also, in LinkedIn, we find one profile related to the company and not much else in the internet, as you can see in the image. In this point is when the attackers carry out an active recognize. Obviously, both activities can be carried out in parallel. So, as we know, the plan is in Switzerland, so we proceed to scan the entire country, looking for any reference to the company. One of the protocol consulted is Snmp, and although since there are not many vulnerabilities for it, it provides information that may be important to carry out an attack. For this, an automated tool was created. His name is Meliodas, and it's launched through the country using the default community stream public. Also, you can use private in order to perform the authentication. Now we will see the information this service can give us. For this, we can use several tools. Now we will use one called Snmp Check, which gives us the data in a pretty way. And as we see, it gives us enough information to work on. But an interesting piece of information is the network connection. And here we can highlight a connection established to port 22, which is generally used for remote administration. And we can see that it is accessible in the image of the bottom. Now we know that someone is connected, so we could assume that it is someone who managed this system, like an administrator. So let's see what we find in this source IP. And with a little more research, we see what type of device it is, in which part of the world that IP address is assigned. So in this case, it's close to San Diego in United States. And the device is a DirectTech router with no vulnerabilities. No. So as a summary of the first step, we have one LinkedIn account, one website, one Linux server, one Snmp service, one InterSNMP IP, and also one internet border device with no known vulnerabilities. So the next step is preparation. In this step, there is weaponization and targeting. Both can take place, but this is not required. So basically, this step is to prepare the tools according to the identified objective. In this case, we will use two vectors, the social engineering one, and the other one we will call it infrastructure. So for the first vector, our goal is that the victim visits a malicious website and exploit a vulnerability in order to take control of her computer. Our excuse will be an interview for a magazine specialized in cybersecurity issues in industrial environments. So for this method, we created a fake profile of a journalist in LinkedIn, Luisa Lancaster. Journalist focused on critical infrastructure, ICS, SCADA. And also, we have a website for the magazine. And here we have our exploit ready to be activated. Okay, now our plan for the vector 2 is also similar to the previous one. We want to redirect all the web traffic to our malicious site, but since we don't know who is behind this device, we need to hack the device and change the configuration of the DNS server. So in this way, the traffic can be redirected to our malicious DNS server. As we don't have the credentials and there aren't no vulnerabilities for this data device, we proceed to find some vulnerabilities. Normally, this type of device, the command injection through the web application is a very common issue. So for that, we must first identify the parameters where we are going to inject our malicious payload. And we identify 6 parameters: action, keypad, login user, login password, from captcha, and our trick. And with this information, we can proceed to create a fuzzer which will be in charge of injecting commands into the previously identified parameters, concatenate the command. So in each parameter, we are going to inject a list of commands to be executed on the target. For example, commands like /bin/cat, /stc/password, or US bin ID, etc. Okay, so once we run the fuzzer, the idea is to analyze the output. So we can see here some internal server error, but it's not what we are looking for. The same process continued with the second field, that is keypad, and in this case, a very interesting response was obtained with the payload number 6 and 7 from the dictionary. So we have found a remote code execution. And now that we have access to execute commands as a root user, we can change some settings on the device. So for example, the domain name servers. Also, we can change or create the password for this device using, for example, a hashcat. Also, we can use the evil DNS script to redirect all the traffic once we change the DNS IP. So when the victim visits any website, for example, like Gmail, the victim will be redirected to our malicious SCADA wired website, which contains the Chrome exploit. So now we can move to the next phase, which is cyber intrusion. And is any attempt by the adversary, successful or not, to gain access to the defender network or system. Also, this phase contains management and enablement phase. And here the actor will establish a command and control using methods such as a connection to the previously installed capability or a intrusion encrypted communications as a VPN. And also, finally, we have the sustain, estrangement, development, and execution phase. And in this phase, documents a number of end goals that an adversary may have. Is the adversary act. So for the cyber intrusion phase, in the vector one, the social engineer one, we are sending the message to Lisa, who is the operator for the Macros Electric power plant. And this is the message. So we use the fake profile for Lisa Lancaster and saying, I know an introduction, like, hi, I'm a journalist for magazine focused on cybersecurity issues, and we'd like to interview you for one of our segments, so you can take a look at our magazine, and we send the malicious website. So when Lisa entered to the malicious website, the exploit is launched, and we can have like control of her computer. Okay, and in the next, the other cyber intrusion phase, in the vector 2, we will change the DNS server for the DryTech router for one DHCP DNS server that we control in the DryTech device. And when the victim, which in this case is the administrator, visits for example, his email, Gmail, the SCADA website will be launched instant. So we can see here the traffic from Evil DNS response. So when he visits gmail.com, we have this IP in green. He was redirected instant to our malicious website that have the IP address in red. And now the exploit is launched, and we have control of her computer too. So for the management and enablement phase, we can automate all these phases using, for example, Metasploit with Meterpreter. And as a summary of the result of the attacks, we had that for the vector 2 infrastructure, we was able to collect a Windows credential for user Jason, also his password, so his Windows password. We also find some VPN files related to Macros Electric and another companies. We also were able to download his KeePass database, a password manager, and also we found some sensitive files in Excel's format. We also were able to take a screenshot of his computer. And now here we can see that he's assistant administrator. We also were able to install a keylogger in order to extract the password for KeePass. And we can see that he has like some entries named SCADA, CM Active Directory. And this is the sensitive files. And this can be also like the same results can be applied to the vector 1, the social engineer 1. So for Lisa, we have here his credential, his password, also his VPN file, password manager. So this is like the summary. We install a command and control system into an IT sysadmin and also an operator user and SCADA engineer. And with this, we have remote access to the plant via VPN, and we can log in with the credential that we extracted from his computers. And now we have like access to the network servers and device for this like company. So now we have the stage 2, and we are starting with the first phase of this stage, that is attack development and tuning. This stage is to create a new offensive capabilities which can affect to the target control infrastructure. So we already in the stage 1 had information about that. They use the Schneider electric device, and we are going to study like the protocol in order to find some vulnerabilities in exploiting. So the attack development in tunnel is about knowing the target, and now we are studying the Modbus protocol, the TCP packets. So we can see that we had a header with a field transition ID with 2 bytes, a proto ID with 2 bytes, length 2 bytes, SID 1 byte, and also we had the PDU and the FN field with 1 byte, and finally the data, which can be from 1 to 52 bytes. So if we see like a Modbus transaction through Wireshark, for example, we can see the field that we previously studied in the previous slide. So si the request is valid, the response will keep the function field with this same value. For example, here in the phishing map, the function code is 01 in hexadecimal, and is related to read coil. And we can see that in the response, in the second image, we have the same function code 01. So the response is valid. But what happens when is a Modbus transaction error? So when this happens, the response for the function code will be the same function code that we send in the request, plus 80 in hexadecimal format. So for example, for the same function called read coils, we send the 01, but because there is an error with the Modbus transaction, the response will be 81, which is 80 plus 1. Also, Modbus define some exception codes. So finally, based on this error message, we can determine the mode of function implemented in the industrial device. So continue with the attack and development and tuning. We are using tools like for recognition of implementing Modbus function So this is a tool developed by DreamLab, and basically you can, it's a Python script, you can put the IP address for the Modbus device, and the tool will tell you what functions are enabling in this device. So there is an importation function with code is 43, and this is for read device identification. So if we send like this request with the function 43, we can see that we have some result from the device, and so we identify like the device. So we can see in this image Schneider Electric, also here and here, and also the version of the product. So with this knowledge, we can now proceed to make some fuzzing in the protocol. So we found that if we use the function 19 and we change the value with a null payload, we can generate the negation of service. So we developed a tool called Modbus Killer, and this is the interface. So basically, you can like send the SID, in which case it can be like 00, or which is like a null byte, and you can provide the host, and we can you can check if it's vulnerable or directly like kill the device. So for the validation process, we had to test this, and we have exploit or tools. We had a laboratory, and we have found the 0 day. So we built this laboratory, and we tested basically the Modbus killer. So I have a video about this process. So let me share with you. So this is our laboratory. And we are using the Modbus killer script, and we can see that the device is working. But we send the kill live parameter. It should stop. It should stop working. And one important thing to mention here is that if you want to start again the device, you have to physically go there in order to restart. This is no way to do it like remotely. Okay, so let's close this. Okay, so now it's time to try our tool, our Modbus killer, into like the real macros nuclear plant, right? And for this, we have another video. So this is the device in the macro nuclear plant. We send the 0-day package. We can see the device. This device this device controls the temperature and pressure of the water. So if we like stop the device, this will be like a big problem for the company. So this is basically the ICS attack. We deliver, install, or modify and execute the attack into the real company. And this was like the flow of the attack that we already viewed. So in this point, our ICS KillChain is now complete, and we can see that from the attacker we use like two vectors. One was social engineering using social media profiles, and we be able to hack a company employee, an operator, and his computer gives us access to the company. And the second vector was launching a country scan discovery. We find some 0-day attack in the DirectTech device, and this gives us access to system administration for the company. Also, just in case, we already reported these vulnerabilities, and they already have their security update. If you have read more details information about, then you can follow these links. Well, some of the recommendation overview is first of all, know and reduce and be constantly monitoring your attack surface. Also, it's very important to be aware of all your assets in order to manage them optimally. And finally, have robust remote authentication system, especially now that the pandemic has forced us to change the way that we work. So thank you very much for your attention. Please visit us in our ICS blog in dreamlab.net, and also you can find the tools and exploit that you use in this presentation in our GitHub repository in github.com/industrial army. So thank you.